of this particular function, or polynomial rather, will just be 16p minus 134. Moving on to example C now. Notice here for example C that we have a function being divided by another function. So in this case, we can employ the quotient rule. And so remember again, for the quotient rule, the way to help us to remember is we say low d high minus high d low over low squared. That's right. So we're going to employ that here. So we start off by saying low, which is the 4 plus t squared, d high, which is the derivative of the numerator, minus high, and then d low. Okay, and then all that is going to be divided by low squared. And so from this point, we see that we'll just write this the same. The derivative of 2t is just 2. Write 2t, and the derivative of 4 is 0. And the derivative of t squared is just 2t. And all that divided by 4 plus t squared, quantity squared. And so from here, we're just cleaning up and combining like terms at this point. So we distribute the 2 here. We distribute our minus 2t here. So this will give us 8 plus 2t squared. Of course, a negative 2t times 2t would be a minus 4t squared all over that again. And notice I'm not multiplying the denominator out because, of course, that's making more work for myself. I'll see later on, after I simplify the numerator, whether it's needed for me to do anything with the denominator at this point. Okay. All right, so here I'm running out of room, so let me go ahead and get rid of this problem. Well, I'll put it back up. And so here, combine like terms, we have 8 minus 2t squared and then we are there. And of course, here we could factor out a 2, but that wouldn't really help us any, I don't think. Yeah, it wouldn't really help us any here because we would need at least a factor of 4 plus t squared to be able to reduce anything to 1. So this is a clean enough way to leave the answer. So here our b prime of t would just end up being 8 minus 2t squared divided by 4 plus t squared, quantity squared in the denominator. Okay, so with that being said, I'll go ahead and make some room and then we'll do the last example. Make sure I remember this. Okay, so for this last problem, here we're going to take the derivative of y, and you see we actually have a combination of the product rule and quotient rule having to be used. So in the numerator, we have two functions, namely 4x to the 5th and natural log of x being multiplied by each other. And of course, that the product of that creates a function, and then we have another function, e to the x, in the denominator. So we're going to start off employing the quotient rule, and as we employ the quotient rule, we'll eventually have to do the product rule as well. So we'll start off, y prime is low d high minus high d low over low squared. So writing it out, low d high minus high d low all over low squared. And of course, here you see where we do the d high, that's where we're going to employ the product rule. So here I could take out the 4, since that is a constant, and then do the derivative of x to the 5th times natural log of x. And so to do that, we employ the product rule, which says I take the derivative of the first function times the second plus derivative of the second function times the first. So taking the derivative of all that ends up in these two terms. And then here we will say minus 4x to the 5th natural log of x times derivative of e to the x. We know it's just e to the x. And all that will be divided by e to the x squared, or e to the 2x. I'm just leaving it like this for now. All right, so I'll go and simplify now. So 4 e to the x, derivative of x to the 5th is going to be 5, and then I subtract 1 from the exponent. So that's going to be 5x to the 4th natural log of x plus natural log of x. The derivative of that is just 1 over x times x to the 5th minus 4x to the 5th natural log of x times e to the x, and all that divided by e to the x quantity squared. Okay, so as you see, this is going to get a little long, but all the hard work is done now. Here we notice that 1 over x times x to the 5th is the same thing as x to the 4th. So we're going to go ahead and simplify that now. And so now at this point, we'll go ahead and combine everything. So here we have 20 e to the x, x to the 4th, natural log of x plus x to the 4th, and then minus 4x to the 5th, natural log of x, e to the x, all over e to the x squared. And so now what we're going to be looking for here is common terms in the numerator and denominator so that we can try to simplify what's going on here. And so if we look, of course, we see that both terms have an e to the x. Okay. Well, let's see, these two terms here both have an e to the x, e to the x. Of course, we have x to the 5th here, x to the 4th here, x to the 4th here. So at least these two terms both have a x to the 4th at least. So we could go ahead and well, that probably wouldn't be the best way to do this. So Yeah, so here it looks like I'm going to make this sort of look like this now to try to make the simplification easier. So I'm going to erase this step and I'm going to rewrite it this way. So here I have 4x to the 5th natural log of x e to the x. So I notice here that if I go and multiply this, I have the 4, the e to the x, and I'm going to have the natural log of x. The only thing that I'm not going to have is the x to the 5th. I'm going to have the x to the 4th. So I'm going to rewrite this way. So 5 times 4 x to the 4th natural log of x e to the x. And of course here, this will be 4 e to the x, x to the 4th. Then I copy this down. And of course, from this point, I notice that I have most of this stuff that's in common. I have a 4 e to the x, x to the 4th in every term. So I'm just going to go ahead and factor that out. So 4 e to the x, x to the 4th. And if I do that, that leaves me with 5 here, natural log of x, plus 4 e to the x, x to the 4th. That's just 1. And then minus 4 e to the x, x to the 4th, leaves me with an x here, and then natural log of x. All that e to the x. Here in e to the x squared is just e to the x times e to the x. Notice that these e to the x's here reduce to 1. And so that's kind of what I was looking for there. And if I go on over here and finish up, notice that both of these terms have a natural log of x in it. So I'll combine these to get something with natural log of x being factored out. So have 4x to the 4th, natural log of x, natural log of x. And so here that would give me a 5 minus x here, and of course plus 1 there. And of course I just have e to the x here. And I believe that's about the best that we can do with that one. Okay. Yeah, that one's a little bit more complicated, but as you see, once you get down to this particular step here, I would say, yeah, once you get down to this step here, it's just a matter of how you want to go ahead and simplify everything. But I believe this is probably the most simple way to do it. And this concludes the video for product rule and quotient rule portion of the differentiation rules.